So, Chapter 1, Lesson 10, and we're going to talk about compare real numbers. So all I'm doing is taking the actual title from the book and use that as the title of our notes. So one thing that you guys should be doing is reading through your lessons. And as we go through the lesson, they have vocabulary listed. One of the major vocabulary was irrational number, but we wrote down that definition the other day as a number that cannot be expressed as the ratio of two integers. So the only one that I'm not sure everybody got written down was for real numbers. So let's write down the definition for real numbers, since that's what we're comparing. And it's actually a system. So I'm going to call it the real number system. And the real number system is the set of all rational numbers. So remember, rational includes all the integers, all the whole numbers, all the natural numbers. So it includes whole numbers, natural numbers, 0, negatives, fractions, decimals, and the decimals are repeating and terminating. So that's pretty much most of what we've talked about. So the set of all rational numbers and all irrational numbers. So all the ones that we can't take square roots of, they're included. So pretty much that's it. Those are all the numbers you've ever studied under one big umbrella called the real number system. So last Thursday, you guys were given a worksheet that you were given numbers, and your job was to tell me all the subsets that number belonged to. And what most people did is they gave me one. And on your quiz that you take, we have at least one, if not two questions that give you a number and say, list all the subsets this guy is part of. So we're going to do a couple of those. So we're going to do our examples right here. So an example would be name all sets of numbers, and I'm copying exactly what the book says, to which each real number belongs. Now the reason why I like to give you the exact wording that you see in the book is because we tend to use that exact wording on your quizzes and tests, and we want to make sure that you understand what they mean. Now, somebody did ask me about vocabulary. Is vocabulary going to be on the quiz? Now, in this particular quiz, we don't have a, here's a vocab word, here's the definition matching. Really what we have is the directions contain those vocabulary words, and if you don't understand those vocab words, then you don't know what you're supposed to do. So that's how vocabulary generally shows up in our quizzes, is not off by themselves, but as part of the directions. Okay, so I'm just going to give you a couple of these examples. So first one, we have 0.2525 ... So what kind of number would we describe that guy as? A repeating decimal. So think about in our chart when we were putting numbers in, where did the repeating decimals end up? They were in the rational part, right? Because they weren't whole numbers. So that took them out of integers, it took them out of whole numbers, and it took them out of natural numbers. So the only place that could go would be rational. Now when it comes to irrational numbers, yes, they are decimals, but they don't repeat. And they don't terminate. Okay? All right, let's try another one. Terminate.
Wait, you said they don't repeat, they don't terminate.
Right. So all numbers that don't repeat and don't terminate are irrational. So irrational numbers go on forever. They don't terminate. And they don't repeat. It's not the same number one after each other. It's always changing numbers, no pattern, nothing there. Okay? Yeah. All right, how about this guy? Square root of 36. Okay. So what would be the... It's natural, because Ben was absolutely right. I did hear him. he first recognized I can simplify that, and I know that the square root of 36 is 6. So that makes him natural. What else? He's a whole number. He's an integer. And he is rational. Okay. What if we had this one? The negative of the square root is 7. Okay, what is he? Yeah, we can't take the square root of 7 to figure out what his negative would be, so that's what irrational is. So again, that worksheet was kind of a precursor to a couple questions that'll be on the quiz. Okay, Jacob, we're taking notes. All right, so remember we talked about this in class. If you can simplify the number, do that first, then what category does he belong to, or categories. Okay. All right, so let's talk more along the lines of comparing. To compare real numbers. So you did an example on the homework from last night, and that was the one that I got asked. The question is, what am I going to do so that I can actually compare numbers with each other that don't look like each other? So if you think to that problem, we had some things under square roots, we could have some decimals, we could have some fractions. What level playing field can I put them on so I can actually compare them? What's going to be the easiest way to compare any real number to any real number? Can I turn all real numbers to whole numbers? Really? I can take square root of 7 and make it a whole number? No, I can't. I can only estimate it. Could I change all real numbers into fractions? The definition of irrational number says it cannot be written as a ratio of two integers. So that throws out fractions. So what are we left with? Yeah. We're going to write everything as a decimal. Which means you have to know how to change a fraction to a decimal. You have to know how to estimate a square root to a decimal. You have to know how to take any repeating number and write it out, either expand it. I will tell you there is a question on the test that asks you to convert a repeating decimal into a fraction. So all the things we talked about are going to show up on the quiz. So let's go ahead and launch into a couple of examples. Some of the problems are going to just be comparing two numbers, and some are going to be giving you 3 or 4 numbers, and your job is to put them in order. And the big thing you have to watch out for is what order they want you to put it in. So fill in, and they're going to give you a circle between two numbers with these 3 symbols, one of these 3 symbols, to make a true statement. Okay, so first thing I want to do is make sure we all understand the 3 symbols. What's this one called? The one I just drew in green. That's your less than symbol. What that says is the first number is less than the second number. Okay, second symbol. This one is greater than. That says the first number listed is greater than the second number listed. And then this symbol we all know as equals. So they're equal to each other. Okay, so those are our 3 choices. So let me give you your first problem. And we've got radical 7, and we want to know how does it compare to 2 2/3. So again, we need to level the playing field, and the only playing field that we can use when we have radicals that are irrational is we have to do decimals. So we're going to estimate radical 7 to the nearest tenth. And then we're going to have to change the fraction 2/3 to a decimal so we can actually do the comparison. So here, what two perfect squares does 7 fall between? 4 and 9. Square root of 4 is 2. Square root of 9 is 3. So my number is somewhere between 2 and 3. But I want to get closer. So we're going to use our strategy, which we keep the smaller whole number, 2. We're going to create a fraction, and the fraction's created by two problems. We're going to subtract our radicand and the smaller of the two perfect squares. Oh, actually that needs to be shifted over. Sorry about that. So we're going to do 7 take away 4 in the numerator, and then the denominator is going to be the difference in the two perfect squares. So at this point we've got 2 and 3/5, and then, oh, that's a terrible 5, sorry. So then what we want to do is figure out what 3/5 is as a decimal. Now a lot of people already know that one without doing the division. 3 goes into 36 times evenly. So this number is the same as 2.6. Okay? Now this guy, we're going to have to figure out what he is as a decimal. So we're going to divide 2 by 3. And 3 goes into 26 times, which is 18 with 2 left over. And what you notice is we just keep having repeating. So this guy is 2.66 ... So going back to our original problem, this is what we're looking at. How does 2.6, thereabouts, compete with 2.66 ... Right here.
2.66 ... is greater because if you compare them, 2.6 is like 2.60 and the other is 2.666.
Right. At this point, now I could, that's as exact or as accurate as we can be at this point. So definitely the 2.6 has less digits. If you look at the hundredths digit of the second number, it has a 6. Ours doesn't have any hundredths digit. So we would say the relationship between the two original numbers would be a less than symbol. And so you need to make sure that when you write your final answer, it goes back to the original problem, not to this estimated one. We did all that work to try to compare those. So this is what I'm talking about on the quiz. You have a lot of this type of work to do to get to your answers. Okay? And just to let you know, your test is going to be multiple choice, which means, not all of it, some of it. But the problem is if you don't show your work and you guess the answer right, let's say the question's worth 2 points, I may give you 1/4 of a point. Okay? Because it's not about can you guess, it's can you prove. All right? Let's do another one. We'll try this one. I forget what it... Actually, that should be example 4. So let's go to example 5. Okay, Kwan, did you have a question?
Yeah. Never mind.
Are you sure?
Yeah.
So here's the next problem. Notice this gets pretty complicated. Can I compare 15.7% to the square root of 0.02? And the answer is not the way it's written. We're going to have to do some work. So we're going to change them to decimals. Now, is 15.7% a decimal?
Yes.
No. It's a percent. How do I change a percent to a decimal? What does it tell us to do? Mike? To the left, how many spots? I couldn't hear you, I'm sorry. 2. So this is per divide by cent, which is 100. So to divide by 100, we move the decimal point left because we're going to get less 2 spots because of the 2 zeros. So this becomes 0.157. Now that's a decimal. Okay. This guy, we're going to have to estimate. So where we're going to put our focus is first on the 2. So what two perfect squares does 2 fall between? 1 and 4. But it's not 1 and 4. It's 0.01 and it's 0.04. Yep, tricky. So then we're going to take the square roots. Now, we talked about this. How do I figure out how many decimals come after the decimal point when I take a square root? So let's go, we'll do this one more time. How many digits come after the decimal point? 2. So we have 2 digits after the decimal. We're going to divide it by the root value. What's the root value? What's the number that's here, the index? It's a 2 because it's square root. So what's 2 divided by 2? 1. So that says you would get 1 digit after the decimal point. So when I take the square root of 1, I get 1, and I put 1 digit after the decimal point. Because 0.1 times 0.1 gives me 0.01. Square root of 4 is 2, but I have to have 1 digit after the decimal point, so it's 0.2. Okay. Now we create our little fraction here, and this is where it gets a little strange. So we have 0.1, and then we're going to do, and we could use estimation with this one as well. We're going to create a fraction, which is going to be 0.02 minus 0.01 over 0.04 minus 0.01. So I have 0.1 plus 0.01 divided by 0.03. So off to the side, I do my long division. Move the decimal point twice, move it twice, bring it up, add a 0. 3 goes into 10 3 times, which is 9 with 1 left over. And then we've got, it's just going to be a whole bunch of 3's. Okay. So basically, we're going to add these two together, which would give me 0.133. So now my job is to compare 0.157 and 0.133. So what would I say to this one? How do they compare? Yeah, the first one would be greater than. Okay, because when you compare this way, those are the same, but this one's larger than the other one. So we go back to the original problem and we say greater than. Okay. Now, you could have kind of eyeballed this since 0.01 is closer to 0.02. Your answer is going to be closer to 0.1. There's no way it would be halfway down the middle of it. So you would say that it has to be less than 0.15. So you can kind of use some logic on that. All right, let's do one more. And then the last one here is going to be the kind that asks you to order. So I think we're at, yep, number 6. So this one, the directions are going to say, order the set of numbers from least to greatest. Now, I'll be honest with you, not all of the questions and even on the quiz may not be in this exact order. So you need to make sure you read the directions and make sure that you're writing your answers the way they need to be written. Okay, so order the set of numbers from least to greatest, and here's your set of numbers. Square root of 30, 6, 5 4/5, 5.36 with a repeating bar over the 6. 30. That's a braces. That's solution set notation. Huh? Not today. So, doesn't matter how many terms. If I'm being asked to put them in order, I need to make them in the same playing field. So I'm going to change all of them to decimals. So the one that's going to require the most amount of work is this guy. So what two perfect squares does the square root of 30 fall between? 24 is not a perfect square. Say again? 22? It's not a perfect square. 25 is a perfect square. And the one after that? What is it? 36. But again, it's not 30, it's the square root of 30, so we're going to take the square root of each, square root of each of these. So I get between 5 and 6. Now that's not really helpful because look at all your numbers. This one's a 6, this one's a 5 something, this is a 5 something. So that gives me 3 numbers between 5 and 6. One number I already know is the greatest, the guy that's 6, right? Because there's nothing that's 6. Everything's in the 5s. So now I've got to figure out where in the 5s. So I'm going to use our technique we talked about. So in the numerator, I'm going to take my number and the smaller perfect square and subtract them and divide that by the difference in the two perfect squares. So we have a 5 over an 11, and then I need to figure out what 5 11ths equals. So I'm going to do long division. That goes in 4 times, which is 44. 6 left over. That's going to go in 5 times, which is 55 with 5 left over. And then if you notice, I'm back to 50, goes in 4, and so we have this. So this number now is 5.45 ... Okay, next number that needs to get taken care of is this guy. How would I rewrite 5 4/5 as a decimal? We talked about how to convert fractions to decimals, Donnie. Yeah, just use division. What's 4 divided by 5? And for us, lucky, it works out evenly. So we get 5.8. So now I'm going to compare this number to this number to this number, and then we've got this guy, which he's okay the way he is because of what's in the tenths column. So which one is the smallest of all of them? Yeah, the 5.36 repeating. What would come next? Hold on. All right, so we got the 5.36. We've got him settled. And then you guys told me which one? So the 5.45 that went with the square root of 30. We have to go back to the original numbers. Okay? So then what came next? The 5.8, which went with the original 5 4/5, and that leaves 6 at the end. And so there's what your answer would be in order from least to greatest. Okay? So guarantee there's going to be a question like this on the quiz. At least one. Okay? So that's what you guys are going to work on tonight for homework.